Okay, gone. All right, and I'll get rid of my face here. Yes, I got a little weird mask here. All right, so we're live. I'm actually taping with what we got going on here. First of all, hey, check yourself before you wreck yourself. Boom. How many people have that answer? Now, notice what I just said about descending order, and this didn't quite do it. They didn't put it in terms of 8 to the 4th being the first term, but just look around, make sure the minus sign's on 14. How many people got that answer? Okay, so I just wanted to make sure that you understood like terms are exact variables, but also the exact exponents that are on them. Quick question? Uh-huh.
Would it matter? So the first two binomials, like, would it matter which one goes first?
No, that's what I was saying. On descending order, what does that mean with multiple variable, terms? I guess there's really no hard rule, especially when the A to the third happens twice. I personally probably would have written this one first because we go alphabetic with A being the big dog, and then after that I'd probably do this one second since it's a tie with A to the third, but that has a higher degree overall. But I'd have to look it up. I don't think there's really a big deal. I'm not marking it wrong at all. Okay. So going back to this, and I guess I should probably just use highlighting for this. So the A to the third, B to the fourth. Luckily, there's no minus sign. I wish I would have had a minus sign that you had to distribute just to make sure you're careful. But yeah, that was the only point of this one, making sure you identify all of the like terms that are exactly the same variable with the same powers. So that ends up being that 11 plus -4, and then A to the third, B to the fourth, and the next one's B to the fourth, or A to the fourth, B to the third, A to the fourth, B to the third. Okay, so that's how we end up getting that. And then, all right, no friends. So that one was all by itself. Good way to think about like terms. Okay, and then real quick on this, yeah, we did some fractions on this one. And your answer should be a fraction, and you probably should leave it as a improper fraction, right? Yeah, mixed fraction is when you do like 1 3/4. No, you'd leave it as like 7/4 for ease. So how many people have that answer? Holy crap! 140 as a denominator? All right, so here's how it starts. We're certainly going to FOIL, all right? But then I want you to understand, and I shouldn't have to write this, but I will. 7/5 times 3/7, these sevens cancel, all right? And I want you to be able to visualize that without having to write it down, all right? That's the point of multiplying fractions. You do multiply across, but you can cross cancel before that happens. So that is why we do get this 3/5 n squared. I'm going to go ahead and write this below here and then show how we get the final answer up here. Next one, nothing cancels. So I have 7 times 7, which is -49. And then 5 times 4, which is 20. And that's n. Then here, this is 5 over 1. All right. So what this ends up being is 15. 5 times 3 is 15 sevenths n. And then last, 5 over 1 times this, that's minus 35 fourths, which you see at the end there as a term. So then how do we get this like term? Well, it's all about a common denominator. And actually, luckily, 20 and 7 have no common factors. So the common denominator is 140. So here's the only thing that you probably had a problem with. What's 7 times 49? And I'm just going to write this down here. So this is -140 as the bottom. What's 7 times 50? This is a trick in math. What's 7 times 5? Let's start with that. What's 7 times 5? 35. 7 times 50 then is 350. It's 1 short of 50 that you multiply by. So just subtract 7 from that. What's 350 minus 7? 343. That's tricks in math and how you can multiply there. How's my math looking? I think this is not going to work. This was a waste of $20. This is supposed to be not fogging up on me. And then 20 times 15. What's 10 times 15? What's 10 times 15? What's 10 times 15? 150. So then double that, and that's what? What's 150 doubled? 300. So these are math skills that you should use in order to, make it easier if it's a no calculator situation. All right, little skills that we can do. And then, of course, add the numerators, and that's how you get that negative 43. Okay? All right, so working with fractions. I had a couple in the worksheet there that I want you to, do when we get to that. All right. I think that's a good start. Hey, where's all my stuff? What happened? Oh, there we go. Okay, and then I really only have 4 examples, 3 of which are just these basic ones. Here's the big deal about, and I guess I did have fractions. Sorry, I built it into the worksheet, but that's okay. We can keep going. So here's all 2-3 is. They call it special cases. And it just, okay, actually, it's funny. We're doing kind of similar stuff in CAT. I'm going to switch these masks. Yeah, that's terrible. What a waste of money. What a waste of money. Jeez, why is this getting all wound up here? Okay. And then we'll get to that last one here. Let me zoom in on these two here. The squareds idea. So we were talking about this in CAT and, what we need to do with this. First of all, is this true as you're writing this down? So square 2a, which is 4a squared, plus square 3b, which is 9b squared. True or false? If you think it's false, raise your hand. Ooh, not many hands up. This is interesting. And I always love when I ask, is it false? Is it true? And then some people can't raise their hand. All right, so is it false? Raise your hand. Hurry up. Hi, and proud if you're there. How many people think it's true? Oh, then you're nervous. We got a couple that are brave enough to raise their hand there, so on and so forth. And the answer is sorry. And this is why people are afraid to raise their hands. This is absolutely positively false. And I want you to write this in your notes. This is a common error. People do this all the time. And I really have to teach that way to make sure you understand this cannot happen. We didn't have exponents yet, but here's what could happen. And I can't really write it with 2a and 3b, but if you had note to self, let me put this off to the side here, 2ab raised to the second, then sure, you do square everything. Notice what's missing. There's no plus or minus sign. So that is the case where you distribute the power. This is called a product raised to a power rule. If a product's raised to a power, then you can raise each individual part to that power. All right? That's not what's happening here. What's happening here is a simple FOIL. So really making a big point today in our short lesson here, don't make this mistake. The first one. Because then obviously you will see that you have a middle term. 2 times 3 is 6. And then we'll go fast on this. And then another 6ab. And then the 9b squared. So we do get those 2 terms, 4a squared and 9b squared, but there's a middle term. All right? And then 4a squared plus 12ab. Now remember what I said. Good FOILers are, anyone remember? Good FOILers are what? Good factors. On Friday, we're not necessarily going to have one exactly like this. We're going to keep it simple factoring. And then Monday, probably, you're going to have to know how to reverse that. All right? And that's actually not too bad. All right, but I want to keep planting that seed in your mind about how multiplying is the opposite of factoring, or factoring is the opposite of multiplying. Total reversal of the situation. And some of your work, when we get real complicated factoring questions, are going to look exactly like this in reverse. Only the worst cases of factoring will I see 4 steps. All the other ones, hopefully you just get it because of pattern recognition. And that's where we need to go. I teach efficiency. So I want you to be efficient, understand a pattern, and factor fast. That is the expectation in an honors class. It's actually my expectation for my CAT students, who I have all seniors in. Okay, and then it's the old annoying fractional work again. I'll just get this done so you have all the time in the world to work. 2 times 2 is 4. 5 times 5 is 25. x squared. That's how you multiply fractions. Multiply the numerators, multiply the denominators. 2 times 1 is 2. 5 times 5 is 25. This one's going to work out real nicely. Same thing. And then this is a 1 over 25. 1 times 1 is 1. So on and so on and so forth. And then the only thing you have at the end there is a middle term. You add the 2's over a common denominator. You do not add those 25s. All right? 1/2 plus 1/2. 1/2 of a pizza over here, the other half of a pizza over here. Put them together, you have 2 halves. You have a whole pizza. 1 plus 1 is 2 over 2. All right, so that's fractions 101, the basics. All right, and then last, well, not last, I do have the classical geometry question. This is not the same, but please watch this pattern. This is one of the easiest to factor in the future. Let's look at what happens to the middle term. All right, 3a times 3a, that's 9a squared. This is 3 times 4, which is 12. You'd be smart, BA or AB, you'd be smart to keep this alphabetic so you recognize like terms. See, I don't want to make this a BA, I want to make it an AB so that I can recognize those like terms. Trying to think of all possible things that students mess up when we're doing this kind of question. And then this is negative 16b squared. Now, what happens to that middle term? What happens to that middle term? Cancels. So this is when we do factoring, this is what we're going to call a difference of 2 squares. Did they do that last year? When you see this, then it's just bam, you just get the answer. There's no 4 steps for factoring. There's recognition, and then there's answer. You're going to go right to here on this, and we'll probably hit this Monday or Tuesday when we have the special factoring cases. Right, so just thinking about that as we get to the more complicated stuff, or at least what students in the past have had the biggest trouble for. All right, so this is a shaded area question, and this isn't too bad. The assumption here is I do have 2 squares, and I don't know if it says so here. What expression represents so here of the 4 white triangles? Okay. So this is kind of a bad drawing because, again, it's an assumption unless I have this, unless I have that, if I see these. You can't assume a right angle, so this drawing is actually insufficient. So add those right angles in there as you're making this drawing. And again, just for the purposes of getting this video done, and I really don't think this is too bad, we don't have a question like this today because I didn't do the book work. I should have, but hopefully this is enough if we throw a question like this on the test. So the question is, what is the expression for the total area of the 4 white triangles? And the answer to that is we're not going to attack each triangle individually and try to figure out what the area is. We're going to think globally and think, all right, when I look at this, if I just need the shaded area here, if I need the unshaded area, that's what's interesting. So it's the area of these 4 triangles, which is the area of the unshaded. This is going to be big square minus small square, because a small square represents the shaded, which is what we don't want. So we want all of this area, but then we want to subtract out this area. And then what's left over is the yellow, right? I don't, it's already visualized like that. I just thought I would do that with some colors here. And of course, area of a square is length times width, or side squared. I could put it like that, x plus 6 squared, and I think that's the point, what they wanted you to do there. Area of a square is side squared, but I'm going to go ahead and make it a 2-2 question, if you will. And then small square is just x times x, which is x squared. So this requires a FOIL. Hopefully you get fast with FOIL. X times x is x squared. 6x and 6x is 12x. We're in honors. We should be able to handle that speed. And then the final answer is simply 12x plus 36. Okay, so writing expressions from geometry looking questions, so on and so on and so forth. Any questions? So really 2-3 is not a big deal. If I would have had 5 more minutes yesterday, I would have kept going and finished that off. But I think we're good. I made a complicated worksheet, and now it's your time to go, and I'll get that to you. Stop sharing. Have a good day.